Welcome to day 2 of Hackfort. My name is David Reyes. I'm a producer and business development manager for Immersive Experience Studios. We're a XR, 360 video, and immersive audio production facility based here in the Treasure Valley. I want to talk to you about a project I had a chance to work on for Boise State's Stein Luminary, where we had a chance to combine AI, 360 videos, and immersive audio. And I want to tell you about some recent developments and then the workflow that we followed, some tools that are available. I really want to make this interactive, so please stop me if you have questions. There's a lot of geeky stuff in here. I tried to minimize the geeky stuff, but there's just a lot. So if something's not clear, please stop me, raise your hand. I'll stop and we'll go back. So I think that the combination of AI, 360 videos, and immersive audio really presents an opportunity to engage with your audience in a way that hasn't been available until like over the last couple of years. You can really immerse them in the brand or the story or the message or the music, whatever it is that you're trying to connect with your audience over. So let's roll the video and then we'll come back to the presentation in just a second. All right, we'll come back to that towards the end of the presentation. It's a very familiar landmark. It's the pyramid just outside the Jump building. So let's talk about some recent developments. So 2020 NeRFs, that is neural radiance fields, are available, right? First paper is published, first algorithms are available for general use. What this is a real game changer for the way 360 videos, right? So I'm going to use the terms 3D scenes and 360 videos interchangeably, right? So a 3D scene, a number of them can be stitched together to create a 360 video. So we start with a 3D scene, put together a bunch of those. This is the first time that neural networks, which have been around since the 50s, are used to generate 360 videos, right? 2021, Dolby makes Dolby Atmos content available on Apple Music. And what this does is this opens the door for Dolby Atmos content outside of the cinema. So remember that up until this point in time, the only people who had access to Atmos were post-production film people. Now you can use it for XR production, video games, music production, on and on. 2023, Gaussian splats are a refinement to NeRFs. They add additional geometry information. They also use some older techniques that are more machine learning related. So back up, neural networks are considered deep learning, whereas machine learning is considered more of an older technique for doing AI, right? What this gives us today is now we have NeRF, Gaussian splat, and immersive audio, and a number of tools available, some of which are free, to create a deeper level of immersion for XR video games, film, mobile apps. Lots of tools to choose from, and really all that's needed is a laptop, headphones, and your imagination. That particular video, I did all of that audio production, all that immersive audio production on a MacBook Pro. So let's compare NeRF and Gaussian splats to traditional computer graphics, right? So if you think about Toy Story, Jurassic Park, right? These classic CGI films, right? Those are all frame-based renders, right? So that is, some artists had to say, okay, this is what this scene looks like, and then they render it, right? This is what this scene looks like, and then they render it, right? They have these huge render farms of all these servers that they use to generate all this data, right? That was cool back then. What we have today is way more powerful, right? So both can render complex, highly detailed 3D scenes. Okay, that's cool. Where it starts to diverge is rendering 3D scenes with view-dependent lighting. So what that means is you've got a 3D scene, right? And you navigate, now you're suddenly on this side of it, right? The lighting changes, right? You want to go on this side of it, the lighting changes, right? You can render that in real time using either NeRF or Gaussian splats. Real-time visualization, to the best of my knowledge, correct me all you computer graphics geeks out there, but I don't know of any applications where you can do real-time visualization with traditional CGI. I know that you can do pre-visualization. You can do some amount of sort of low-res, get some idea that you're on the right track. But with NeRF and Gaussian splat, you can visualize it real time so that if it doesn't look the way you want, you just stop, go back, refine the model, refine the data, change the images, and start over again. So it gives you a more interactive and more iterative way to generate 360 content. 360 videos from 2D images. There are some ways to do this with computer graphics, but it's really difficult. This is done in video games sometimes, where you've got a 2D image as a background that's meant to look like, to mimic a 360 environment. But in the strictest sense, taking a 2D image and generating a 360 video is not possible, to the best of my knowledge, with traditional computer graphics techniques. So let's keep rolling. So novel 360 views. So again, you have these 2D images, right, that are the source material for the NeRFs and Gaussian splats. You can create a view using this technology, and I'll show you how in the workflow, that isn't in the original 2D images. That's what we did with that jump video, right? Those whooshes when we're running through the pyramid and stuff. The person who worked on this project with me, she just went around that pyramid and shot a bunch of 2D images. She didn't actually jump inside the thing and shoot photos inside of it, right? That was all stuff she generated using NeRFs. And then lastly, interactive 360 videos, right? 6 degrees of freedom. You can determine not only how the camera moves and how the lighting moves, but also how the viewer is seeing the scene. And that's really great for VR, AR, right? 360 videos, right? All that sort of thing. I'm gonna pause for a second because I talk really fast. Do you guys have any questions? Anybody lost? Yes, sir.
How does the resolution of the picture taken affect how accurate it is?
Yeah, that's an interesting point. Not very much, because what we're doing is we're extracting information from the images and creating a data set, and that's the thing that's rendered, right? So there's an intermediate step. So instead of just using real live video, right, or real live images, we're actually doing an intermediate step, creating what's called a point cloud, a series of point clouds, and that's what we use to generate the images. Yes, sir.
Is it using a system like RTX?
Yeah. Yeah, exactly, right. So, of course, we're talking about computer graphics, so this, and AI, right? So, of course, NVIDIA's here, right, in many locations. So, their tool, InstaNeRF, was one of the early implementations of the NeRF algorithms, and that's, to use their product, you have to use their graphic processors, their GPUs. Okay, any other questions? All right. We're going to continue geeking out here. Okay, so lots of tools, right? So I tried to hit the most important ones, the ones that are the easiest to access. And if you want a copy of these slides, you can feel free to contact me after, and I'll also share a copy of the video so you get some idea of what you can do. We'll come back to the video because there's some things I want to talk about in that video that went well and maybe not so well. So yeah, we talked about Instant NeRF. So thanks for the lead in there, right? This is NVIDIA's product. It's fast, it's accurate. You couple this with one of their high-end GPUs, this thing it's like a rocket ship, right? It'll go super, super fast, which is remarkable. It's also great if you've got a deadline and you've got lots of stuff you need to render, right? Text to NeRF, this is using text prompts to generate 3D scenes. For Gaussian splat, Scaniverse, which is the Niantic tool, I really recommend that because Niantic couples that with spatial information, right? So not only are you rendering 360 scenes, but it has an awareness of where you are on the planet, which is pretty neat. Polycam is a mobile app, and it guides you through this image capture. I think you do a great job with the UX on that. NeRF Studio, that's one of the older tools. It's an open source pipeline for NeRF and Gaussian splat. And then Luma AI, probably the most popular AI tool out there for generating 3D images, 360 videos using AI. For immersive audio, I could go on and on about this for days, but I won't. Dolby Atmos, of course, the 800-pound gorilla in the room. They dominate the space, largest ecosystem, largest number of titles, largest number of supported platforms. But there are others. There are actually a total of 38 solutions. One of my favorites is Sound Particles. This is a small startup in Portugal. They do some really, really innovative work. What they've essentially done is created a particle system for immersive audio production. Really unusual approach to immersive audio production. For that video, I used a couple of their products, Skydust 3D and Energy Panner. And then a very recent entrant in the space is Admoki. This is a company out of Austria, and they are a preferred vendor for Niantic. So if you want to do immersive audio for AR, there are very, very few solutions for that, for augmented reality. That's a great choice. So I kind of hit on the top three. There are many, 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 many more. Any questions? Yes, sir.
About Luma AI, do you know about like where its database gets its images that trains this AI from?
No idea.
Legally obtained?
No idea.
Because there's some visual training AIs that take photos from people on the internet without their consent.
Yep. Yep, that's one of the issues with AI, right, is copyright. I mean, it's a great tool, right, but we've got to get this sorted out. Same thing with music that's generated from AI, right? Billie Eilish, there's been a number of artists who've come up and said, hey, you can't use my music to train your model, sorry. Or you got to pay me money. Yep. Okay. So here's the workflow that we followed for the video, and we'll go through this, and then we'll go back and look at the video so you can understand sort of the making of, kind of behind the scenes, right? So we used the instant nerf tools. So this is strictly nerf. It's not Gaussian splat. I think the next project we do, we're going to use Gaussian splat. Right, so install the tools, right, compile. There's actually a bit of work involved here. Capture the 2D images, right? There's a Python script, which I'm happy to share with you that kind of runs the render. So that's how you get that whole rotation and movement through the scene, right? That's what dictates the movement and the lighting. You train the nerf model. And then refine the images, script and a model, right? I'd love to tell you that this is a slam dunk. You shoot your images, you upload it, and you're done, right? They will tell you that in the marketing video. It's not quite so simple. There's actually a bit of work involved. Same thing with immersive audio, right? There's no shortcut here. There's work involved. However, the result can be really, really stunning, really amazing, right? So you refine, and then you generate a 360 video. This is a video with no audio. That's what I received from Boise State when I started on this project. You'll notice in the video there are these clouds. Those are artifacts, and what causes that is when you have images, when you're shooting your 2D images, when you have images that overlap, or in this case you have objects like the pyramid, where in one image it's closer than the other. I suppose the only way to eliminate that problem would be to set up some sort of a camera rail system around the object so that you know that you're consistently at the same distance, or just have a tape measure and just be really, really careful and really accurate, right? That wasn't the case here. Go ahead. Yeah.
Does that artifacting you experience, would that relate to how artifacting in video games when you're using upscaling technology?
Yeah, that's interesting. I think it's a related problem, right? In this case, this is the tricky thing about AI, right? Is it's non-deterministic, right? So A does not always equal B, right? So you can take a bunch of images and upload it to this service, or store it on your machine and have the NVIDIA tools process it, right? But what you put in is not necessarily what you get out, right? And that's the hard part about this, right? Is that you have to sort of understand what the model does, what the tool does with the data that you've given it. So in this case, there were overlapping images where portions of that pyramid were either closer or further away in those images, right? And so when the algorithm looks at that, it says, well, I don't know what to do with that. So that's how you get those clouds, right? And we spent some time refining them, but quite frankly, we ran out of time. So here we are. Right. So, yes, go ahead. Potentially. Yeah, potentially. So that's actually a really interesting point. Gaussian splat, and I must admit, I don't have a whole lot of experience with Gaussian splat yet, but Gaussian splat, as I understand it, does a better job with those kinds of large lighting changes or large dynamics in the lighting over nerf, right? So if you think about kind of the pros and cons, right? Nerf is really fast, especially if it's coupled with an NVIDIA GPU, right? Gaussian splat is a much bigger data set, takes a lot longer, but it does a lot better with dynamic changes like lighting. So typically you want to shoot about 50 to 150 images. I'd say to be safe, maybe 200, just to give yourself a nice round number. The Python script, as we said, dictates the movement. Anticipate some refining. So when you are thinking about a deadline or thinking about a deliverable for a client, like I did, or a project, give yourself some extra time so that you have time to refine and improve both the output as well as the model, the images, that sort of thing. And of course, the output is an MP4 video. So, yeah, go ahead.
I was just going to ask, once you give it all the inputs, how long does it typically take to create the first version of the rendering?
The nerf is pretty fast, especially if you're on a fairly recent NVIDIA GPU. Like you said, if you've got like an RTX class, right? You know, it's anywhere from, depending on the length of the video, it's anywhere from, you know, a couple of minutes to maybe, you know, 5 minutes, 10 minutes, something like that. It doesn't take, it's not like hours, right? If you've got longer, like if you've got a full length feature or, you know, like a 30-minute video or something, it could take a while. It could take a few hours. So the goal is, you know, the recommendation is start with shorter chunks. You know, like if you've got this long sequence, let's say you're doing a short or indie film or some sort of a 360 experience, like a VR film or something. Take specific scenes that they're really important, and focus on those first. Get those dialed in first, then go back and render the entire thing. Yeah. Because otherwise you'll waste a lot of compute time, and you have to go back and refine it anyway, right? Right, and so the output is MP4 videos. So now you can put that up on YouTube, you can view that on your mobile phone, pretty much anything and everything that plays MP4s, even like your Roku and Apple TV, you can play MP4s on those. So that opens up a lot of options for you. All right, let's keep rolling. So the immersive audio workflow. I used Ableton Live Suite for this, just because I really like their interface. It's a fairly easy tool to use. And then, as I said, Sound Particles, Skydust 3D, and Energy Panner. Skydust 3D is particularly noteworthy. It's the first immersive synthesizer. So that is, it's an 8-voice synthesizer where you can take each of the voices and place them in a particular location in 3D space and then move them around. So I think that's a game changer. I'm surprised that there hasn't been more press around Skydust, you know, in sort of, you know, trade magazines, online, that sort of thing. But I think it's a really remarkable product, which is why I chose it for this particular project. Energy Panner, what it does is it moves objects around in 3D space based on where the energy is concentrated. So you can like set a filter and say, you know, if it's a lot of bass, you move it around. If it's a lot of high energy, you can move it around. Pretty innovative tool. One thing about immersive audio production is, and I'll walk through the workflow here in just a moment, is because of the way our ears are shaped and the size of the aperture, our ears are a lot more sensitive to movement with sound sources, so sound effect, music, drums, whatever it may be, that have a lot of energy above 1.5 kilohertz. That's just a rule of thumb. Things that are below 1.5 kilohertz are a lot harder for us to localize. So for example, if you're sitting at a stoplight and there's somebody in a car next to you who's got a lot of bass going, you know, they've got the subwoofers going, it's really hard to tell which car that's coming from because your ears don't localize bass very well. The bass just kind of goes everywhere, right? Whereas higher frequency, your ears are a lot more attuned to the location and the movement of those sounds, right? So you can use that to your advantage when doing, you know, VR, AR, 360 videos, right? That's how, you know, Dolby Atmos, Dolby Vision content is produced, right? They find these sound sources that are concentrated above 1.5 kilohertz, and that's what they pan and move in a 360 space, right? Whereas if you did something, let's say at 200 hertz or 400 hertz, right? You could create movement in that with that sound source, but your ears wouldn't really pick it up very much, right? So in this particular video, the sound effects, like that at the very beginning, right? That sort of comes down from here. It's hard to hear because I've only got this one speaker. You really need to hear it either with headphones or with a multi-channel system. But the high-end sound effects, the synth parts, the lead synth parts, the sound effects, those all have movement in them, whereas the drums and percussions are just sort of sitting at the bottom. It's just kind of a bed because there's no real point in spatializing those. So. Right, so install the DAW, we create or buy the music, determine which sound sources you're going to keep static and which ones will have rotation or movement, refine the audio, render the final video, and then upload it. That's basically the workflow. Yep.
For the audio, is
Yep.
it like trying to accurately replicate audio? It's like ray tracing, that's like trying to actually represent what light does, but when it's generating audio, is it doing it in like the same way? It's like sound travels through objects and
Yeah.
like bouncing off of everything.
Okay, yep, good point. So it's not AI generated audio. I created all that audio, and it took a long time. And what we're doing is we are creating an ambiance, a sound field, and we are following or tracking the movement in the video, right? So that's kind of the goal, right? Is that when we look at this video, it's on a flat screen. We're not in a headset. We're not in an immersive theater, right? You know, the Stein, Luminary, anything like that. We actually prototyped this on flat screen, then went to VR. So to really make it feel like a true 360 experience, a true immersive 360 experience, the audio kind of helps fool your brain into thinking that this space is much bigger than it really is, right? So I'll give you an example. My oldest daughter, Olivia, she's a huge fan of Gladiator 2, Gladiator 1, Gladiator 2. So we went to see it in Dolby Atmos. That was remarkable, right? You can hear stuff flying around up here. It was really, really cool. Went back a few weeks later, they had moved it to a different theater that only had surround sound in it, right? Nothing against surround, nothing against quad. Those technologies are great. But when I listen to the film again, I go see films not to watch them, to listen to them, right? Because I'm an audio geek. So when I listened to it the second time, to me, it felt like they had essentially taken the movie theater and like squashed it by about 10 feet, right? It just felt like the sound field was just really, really low and sort of very focused, right? And so that's the trick with immersive audio. It is decoupled from the video, to your point, right? We're not really generating audio from video. I'd love to do that. I think there are techniques for doing that. I've not tried any yet. But this was manually generated, the old-fashioned way. And what I did was I looked at all the different hit points, right? So, when does it transition right? When does it transition left? When do we run through the pyramid? When do we come out of the pyramid? When do we come down? When do we go up, right? And so the deal is, as a composer, is for me to hit all of those points in a way that's significant and meaningful. And I don't know how else to describe that other than you just have to do it to sort of figure it out. Yeah. Does that answer your question?
Kind of, sort of.
Okay, go ahead.
It's like a very complicated thing to explain. Like, with
Yep.
ray tracing, you simulate light bouncing around the sun next differently, so that would be complicated.
It does. Yep. Yep. Well, I mean, so potentially, right, what you could do is you could take some of the point cloud data that's available, right, from the Gaussian splat and use that somehow to synthesize music. I think the issue there, though, is that you need some sort of a rule-based engine. Sorry, we're geeking out here. To tell the algorithm what makes a great melody and what doesn't, right? That's.
Oh no, I'm not talking about like generating like new music. I'm talking about like generating like the distance of the music and like the sound waves. Like,
Oh, I see.
yeah.
Oh, I see. Okay, yeah. So you could probably do that if you had a game engine, right? Like if you were using Unreal or if you were using Fmod or Wise, one of those intermediate tools. We didn't do that here because we had a pretty limited budget and pretty limited time. But that's actually an interesting idea. So yeah, if you had all of this inside of a game engine, and that's the kind of the next project we're working on, is to do this inside of Unreal rather than just sort of pre-rendered and then we score it. Doing this in Unreal would give you that positional information, which yes, you could then use to generate your audio. But the issue I see is that you'd need some way to take that information from the game engine back to your DAW, right? So one of the issues with generating immersive audio for VR, AR, 360 video, film, and all that is that you have essentially two workflows, which is why I represent them this way, right? You've got the one where you generate the video, and you've got the other where you generate the audio, because they're different tools. To the best of my knowledge, there is no digital audio workstation that'll generate 360 videos. Not yet, anyway. So you create the audio somewhere else and you import it to the game engine, or you import it into your nonlinear editor or your tool, right? So you need some way to feed back that distance information in real time, well, with time information back to the digital audio workstation. Does that make sense?
Yeah.
Okay, I can, if you want, we can catch up afterwards and we could map this out. That's all right. That's all right. Okay, so then the last thing, we talked about static sound sources, dynamic sound sources. So in the world of Dolby Atmos, static sound sources are called bed audio, and dynamic sources are called object audio. And you may have heard that sort of, object audio. There's no magic there. All they're talking about are sound sources that you move in real time. One last thing is, which is a nice lead in, when you're trying to determine where to place the objects, the way you do that in a digital audio workstation is through automation, which is metadata that you essentially either draw or you calculate or you figure out. But essentially what you're doing is you're telling the audio workstation, at time 0, this object sits here. At time 1, this object moves over here. At time 3, so you're telling it, moment by moment where this thing is going, right? And the magic of Atmos and these other technologies is that metadata follows the audio from the digital audio workstation all the way to the device that renders it. All right.
In Skydust, you said it places in 8 locations.
Yeah.
How are those locations described?
Sure. Yeah. Skydust 3D is a virtual synth. So most synthesizers have anywhere from 4 to 8 oscillators, right? And so in this case, there are 8 oscillators, and those oscillators can be placed in any position in 360. So there's a window, there's a setting where you can just say, well, I want oscillator 1 to be sitting here in the front, and I want oscillator 4 to be sitting here in the back, and you can move those in real time. Yes, sir.
That's in relation to the camera, or is that in relation to objects? Are you placing it in?
Yeah, that's interesting. It's relative position, right? So in this particular case, because we had 2 separate workflows, right, I had to make the determination of, based on where we are and where we're rotating, where that should be in 360. If you're in a game engine, to the earlier point, you'd have a much better way to say, in this zone, this is where this should live, and then in this zone in 360, this is where this should live. But because we had 2 separate workflows here, we didn't really have that option. So, so some applications, right? I mean, I can think of many. Think about like a real estate virtual tour or a travel, log, right? Virtual tour. You could do this absolutely with a 360 video, right? Shoot a bunch of 2D images. For marketing, you have a product, or you have some idea, you have something that you want to show. You shoot a bunch of these images. You create a 360 video, put some music to it. Product demonstrations, right? Customer presentations. Rather than sort of doing PowerPoint as I've done, you could actually do the whole thing as a 360 video. For industrial simulations, manufacturing, energy, things like that, things that it would take a lot of money and a lot of time to pull all these components together, you could absolutely do something in 360 video. Training and education, data visualization, and I think healthcare. I think there's some applications for this in healthcare. I haven't explored those yet myself, but hope to at some point in the near future. And then if you want to learn more, so a couple of things. There's lots of resources about NeRF and Gaussian splat, no shortage of them. I picked, I think, some of the better ones that are out there on the internet. In particular, this paper by Matthew Tansik was the first paper on NeRFs. The New York Times Field Guide is really good. So if you want these slides, you can feel free to contact me. I'll give you that information in a moment. I developed a course on immersive audio with Alan Parsons and his crew, Art and Science of Sound Recording. To the best of my knowledge, it's the most comprehensive course that's out there. Downloadable projects, quizzes, interviews with Alan. I mean, there's just a ton of material. It was a 2.5-year project, so it was pretty significant. We've got some discount codes for that. If you're interested, if you want to scan the QR code, I moderate the discussions, and I also critique the projects. I think that immersive audio, there's a space that there's a lot more room to grow there. If you listen to any of the mixes that are out on Apple Music, there's still some challenges out there, right? When you're coupling that with 360 video, it makes it even more complicated. And then if you want to follow up, I want to give credit where credit is due. Rezvan, the PhD student that I worked with at Boise State, she generated all of that video. So she shot the images, she generated the videos, did all that work. I created the immersive audio. We're planning to team up for another project this coming semester. This one with a game engine, so it should be a lot more interesting. And we present these like in VR and then at the Stein Luminary, which I highly recommend. It's a $2.5 million room in the Fine Arts Building at Boise State. It's got floor-to-ceiling flat panels. It's a remarkable space to have here in Boise. And you can contact me over email. Yes?
In the Luminary, what, I've been there, but do
Yep.
you have an audio, is there immersive audio as a part of that?
No. That's another project that I work on. I've been consulting on that museum almost since it was conceptualized. It's been a long time. There's a 5.1 surround system in there. It's not very well set up the folks who did that install, unfortunately, were not really audio people. So yes, there is sound. No, it is not immersive. So I've been pushing them to get some height speakers in there so that we can actually render Dolby Atmos. I think we'll get there at some point. We're just not there yet. There's some new leadership that's taken over. So for now, what you can do in there is surround. So you can take an immersive mix, fold it down to 5.1 and then render that in the room. But it is a remarkable space. 8 4K projectors, floor-to-ceiling panels. The room is a little bit smaller than this. So you've got flat panels all the way around on 3 sides. The sound system sits up above, and then the flat panels have touchscreens on them, so you can move things around. So it's really neat. I mean, the fact that we don't have to travel to New York or LA or, someplace outside of the state to experience something like that, I think is really remarkable. It's a great room. I just wish we could have more presentations in there, more activities in there. So you can feel free to contact me, Immersive Experience Studios. My email, I'm on LinkedIn. If you want a copy of the slides and the video, you can just do the contact us form, and I'm happy to share those with you. And if you have other questions, you can feel free to reach out. We're going to go back and listen to the video one more time. There we go. And I'll hang around for questions, but that's pretty much what I have for you today. Short but sweet, but hopefully you can take advantage of some of these techniques in the work that you're doing.
Thank you.
Thank you.